Good morning. Today we will discuss the topic that is ocean currents. Now, in our previous class, we discussed that how energy and mass that will circulate or that will interchange from atmosphere to ocean and sometimes ocean to atmosphere. Now, the energy that is transfer from atmosphere to the ocean bodies that is mainly responsible to guide the circulation or movement of ocean water. Now, oceans are very large bodies of water, and when this water is in motion, that is called current. The phenomenon are formed that can be simple or that can be guided by various other processes apart from the atmospheric energy transmission. Now, ocean currents basically are the masses of ocean water that flow from one place to another. The amount of water which is blown away by the oceans that can be large or small. The direction toward which it moves, that is the ocean water moves, is called set, and its speed is called drift. Now, wind, or more specifically wind belts, they transfer about two-thirds of the total amount of heat from the tropics. We all know that due to different insolation over the Earth's surface, the Earth's surface heated differently at different latitudinal conditions. The equatorial region that gains the maximum amount of heat, whereas the polar region that it receives much lower amount of energy. Now, due to this energy imbalance over different latitude conditions of Earth, different areas of Earth heated differently. Now, ocean currents are one of the responsible agents by which about one-third portion of the total Earth heat redistribute globally. So, due to this, the lower latitudes, that is the equatorial region, they does not become too hot, and the higher latitudes, that is the polar region, they does not become too cold. Now, the current of oceans, that is the movement of ocean water, that can be modified, although there is a large trend or large pattern, that is ocean water move from the equatorial region towards the polar region, but this simplified motion of water is not so simple because of the different distributions of continents and oceans. Not only the distribution of continents, but the shape of the continents also plays a vital role in the ocean current direction. The ocean currents are mainly of two types. The first type, in which the ocean water moves along the sea surface, that is mostly restricted in the upper few meter of the ocean surface, and it is majorly influenced by the wind movement. So this current is mainly occurs due to the friction of wind with the atmosphere, and that frictional force basically enhances the movement of ocean water from one point to other, and that is mainly restricted along the superficial condition of the ocean water. The second type of ocean water movement is found as thermohaline circulation, which is mainly formed due to density contrast in the ocean water. And this type of current or this type of flow of ocean water is known as deep ocean currents or simply deep currents. Now, ocean water movement can have a huge importance to the living body, all the living bodies of the world. It is not only important to human perspective, but all the living bodies or the living entities of the earth, they are somehow get benefited or they are somehow affected by these ocean currents. Moves Ocean currents moves drifting organisms from one place to another, so that basically uh, controls the distribution of organisms and particularly the floating ones, that is the planktons. So the planktons can be distributed globally and they show some pandemic distributions with the help of ocean currents. Ocean currents carries eggs and larvae of organisms that have external fertilization. So whenever the male counterpart and female counterpart are spread externally by some organisms, even it is also found in the some aquatic plants also, then the fertilization process occur externally, and in this case ocean water acts as a carrying agent to meet the male and female counterpart together, and fertilization occurs after that. Thirdly, ocean currents along with them brings food, that is brings nutrient, brings oxygen. So a regular like nutrient, oxygen, that is regularly a regular circulation occurs. Ocean currents carries away pollutants and waste. Just in the few days ago, if you look at the Western Indian cyclonic storm Taute, after the uh, blown over of Taute, when ocean water are highly uh, overcome, that the ocean water is very high, and after the cyclonic storm of Taute, it was found that almost all the beaches of Maharashtra, particularly all the beaches of Mumbai, the waste, the pollutants, the plastic bottles, garbages, which are thrown by the humans to the oceans, they are again thrown back to the beaches. So you can get an idea with slight change in energy condition, the pollutants, the waste, all other things that can be carried by ocean currents from one place to another. Ocean currents also maintain temperature throughout the earth, and that is why cold areas feel less cold due to receiving of the warm ocean current. Currents play an important role in the navigation of ships also. Now, if we look at it, the ocean profile, that is the change in certain physical factors with respect to depth, we found some distinct zones. Firstly, if we observe or if we look at the oceans temperature variation with respect to depth, we found that there is a zone within the ocean water when the drop of temperature, that rate is very high. This zone is known as thermocline. You can see that above this zone, with depth, the temperature drop is occurring. Again, below this zone, temperature is dropping with depth. But here in this portion, the rate by which temperature change, that is exceptionally high. So this zone is known as thermocline. Similarly, if we look at the salinity change with respect to depth, again we found that there is a zone where change of salinity occurs more rapidly. That is a particular zone within the ocean water. Below and above of this zone, the change occurs in a steady state. But in this zone, the change of salinity, the change in the amount of dissolved salt is very rapid. So with respect to salinity, this zone is known as halocline. Thirdly, if we look at the density of the oceans, change in density of ocean water with respect to depth, again we found a zone where the change in density is abruptly high compared to its upper and lower portions of the water. This region or this zone where the uh, density change is very rapid, that is known as pycnocline. Now, this pycnocline is very important because it is the density of ocean is dependent by the change of some other physical factors like temperature and salinity. And this pycnocline acts as a boundary for the surface ocean currents and the deep ocean currents. Most of the surface ocean currents that occurs above the pycnocline, whereas the deep ocean currents that occurs below the pycnocline. Now, if we look at the pressure and density conditions of the ocean water, we found certain cases where the change of ocean water pressure from one point to another, that goes or that lies parallel with the change in density from one point to another. So here you can see that's black line. These are the isobaric surfaces. That means along this line, all the points have equal pressure. And this blue line, that are the isopycnic surfaces. That means along this line, the change in the value of density is equal all in these points along this line. Now, you can see the occurrence of these isobars and these isopycnals can be of two types. In the first type, where the isobaric surfaces and the isopycnic surfaces, they occurs more or less parallel to each other, so they never cross cut each other. This condition is known as barotropic condition, and in this case the fluid is known as barotropic fluid. In contrast, in the right hand picture you can see that the isopycnic surfaces and the isobaric surfaces, they are cross cutting each other. So here these two surfaces are not parallel to each other. This condition is known as baroclinic condition, and the fluid is known as baroclinic fluid. Now coming to the types of ocean currents. Ocean currents, as I already told you, that can be found at the surface or at deep below. The ocean currents which found at the surface, that are known as surface currents, and these are mainly wind driven currents. These are mainly found to occur by wind activity, and mainly these are occur, that means the motion in this type of current occurs in a horizontal fashion. In contrast, the deep ocean currents, here no question of wind activity, rather the movement of ocean water occurs due to density contrast of water in different places, in different points, and that density difference occurs due to difference in temperature and amount of dissolved salt within the ocean water. In this deep current, the movement of ocean water occurs both vertically as well as horizontally. Now, the surface currents which occurs within and mostly above the pycnocline, it occurs up to a depth of about 1 kilometer and affect about 10% of the world's ocean water. Because if you look at the depth profile of the ocean, the pycnocline occurs very close to the ocean surface. So in surface currents, only these surfacial waters above pycnocline, that is affected. So that is why the 10% of the ocean surface water, 10% of the world's ocean water, that is the surface water, is affected by the ocean currents. Surface currents develop from the friction between the ocean and the wind that blows across its surface. Only about 2% of the wind's energy is transferred to the ocean surface, and that causes the horizontal movement of the surfacial water. Now, if in the earth there were no continents, the surface currents would generally follow the major wind belts of the world. But in reality, it was found that ocean currents are driven by more than just the wind belts of the world. The distribution of continents on Earth is one of the main factor that influence the nature and direction of the flow of the surface currents in each and every ocean basin. Apart from the distribution and shape of the continents, there are other factors also, like the Coriolis effect, the gravitational force, and the friction that also plays a significant role in these surface ocean currents. Now, coming to the Coriolis effect on these surface ocean currents. Now, the Coriolis force, or rather, it is more scientific to call it as Coriolis effect. It causes moving objects in the northern hemisphere to rotate in clockwise or rotate in the right side, and in the southern hemisphere to rotate counterclockwise, that is to the left hand. And this rotation of moving objects across latitude occurs due to the rotation of the earth around its own axis. So this is a apparent motion found to occur due to the rotation of earth. So all the moving oceanic surface water which cross latitudes from equator to polar region, they rotate in the right side towards east, whereas the water in the northern hemisphere which is coming from polar regions to the equator regions, that moves to the right side towards the west western part of the ocean basins. Similarly, in the southern hemisphere, the water moving from equator to poles, that moves to the left, and water coming from polar regions to equator, that moves to the left, to the west, and hits the western part of the ocean basin. Now, the moving water which is occurred due to the uh, action of wind with the ocean surface water, that water moves in a large circular loops. So although in general we are uh, predicting that the ocean water moves from equatorial region to polar regions, but in reality, uh, most of the equatorial water, that is restricted within the tropical subtropical region, and the polar water, that is restricted within the polar to subpolar regions. So there are two regions in which the surface ocean current moves. Now, although there is no such any barrier which restricts the flow of ocean water from one basin to another basin or one latitude to another latitude conditions, but ocean currents, they can be organized with the help of some broad discrete patterns found in each oceanic basins, and this discrete pattern is found to occur in the form of some large circular loops of moving water which are known as gyres. Now the gyres, that is these circular loops of moving ocean surface water which are restricted in the subtropical region, those are known as subtropical gyres. The gyres, That term basically comes from a Greek word that is gyros, which means a circle. So from that gyros, the term gyre came, which indicates circular moving loops of water. Now, generally, each subtropical gyre is composed of four main currents that progressively flow into one another. The main currents found in the subtropical gyres are the equatorial current, which is mostly found to occur close to the equator regions, the western boundary currents, that is found to occur along the western margin of the basins, the northern or southern boundary currents. Northern term used for the northern hemisphere, this one is the northern boundary currents, and southern term used for the southern hemisphere, this is the limit, higher latitude limit of this subtropical gyre. And lastly, the eastern boundary currents found to occur along the eastern margin of the ocean basins. Now, all these currents are restricted more or less within the 30-degree latitude in both hemispheres. So that is why they are known as subtropical gyres. Now, coming to the equatorial current. These currents are mainly affected or mainly formed by the trade winds. The trade winds which blow from southeast to northwest in the southern hemisphere and northeast to southwest in the northern hemisphere. These trade winds actually set a motion in the ocean water mass between the tropics, and the resultant water movement is almost uh, more or less parallel to the equator, more or less parallel to the 0-degree latitudes. So that is why it is known as equatorial current. Second, the western boundary current. When the equatorial currents reach the westernmost portion of an ocean basin, they must turn because uh, due to the occurrence of land masses, they cannot cross the land mass, and it is the western margin of the ocean basin. So when they hit the westernmost margin, the landmass, they will move. Now, the Coriolis effect that deflect these currents away from the equator along the western boundary of the basin. These are known as western boundary currents as they are moving along the western margin of the ocean basins. Now, the water found to occur in these western boundary currents, they are found to carry warm water because these water are coming from the equatorial regions towards higher latitudes. So from warm condition they are moving towards cold condition. So this surface water is basically warm water current. The third one, that is the high latitude boundary of the subtropical gyre, the current that is northern or southern boundary currents. This current occurs due to the prevailing westerlies that blow from the northwest in the southern hemisphere and from the southwest in the northern hemisphere. These winds direct the ocean surface water into an easterly direction movement and cross the ocean basins entirely. From the western margin of the basin, the ocean water cross the basin and reach the eastern margin of the basin. In the northern hemisphere, these currents occurs along the northern margin of the ocean basin, whereas in the southern hemisphere, these currents occur along the southern margin of the ocean basin. So that is why these currents are known as northern and or southern boundary currents corresponding to both hemisphere. And the last currents found to occur in the subtropical gyre, that is the eastern boundary currents. These currents are found to flow in the eastern side of the ocean basins in both hemispheres. The continental barriers and the Coriolis effect, they turn the ocean water of this high latitude ocean water, that is the northern or southern boundary currents, they turn this water towards the equatorial regions, and this surface movement of water, as it is found along the eastern margin of the ocean basin, so it is called eastern boundary current. Now, in contrast to the western boundary current, where most of the superficial water is found to carry warm water because it is coming from the equatorial regions towards high latitudes, the eastern boundary current, as it is coming from the high latitudes to the equatorial region, so it carry mostly cool water towards the lower latitudes. So you can see that in this subtropical gyre, different temperature condition and movement of that warm and cold water in across different latitudes, how they control the temperature distribution across latitudes. Now, it is found that in the world there are 5 subtropical gyres. Basically, oceanographers recognize these 5 subtropical gyres, and those are found in the northern Atlantic subtropical region known as North Atlantic subtropical gyre, or also known as Columbus gyre. Second, the South Atlantic uh, subtropical gyre, or also known as the Navigator gyre. Third, the North Pacific subtropical gyre, also known as Turtle gyre. Fourth is the South Pacific subtropical gyre, or also known as Heyerdahl gyre. And the fifth one is the Indian Ocean subtropical gyre, or also known as the Majid gyre. Now, the reason they are called subtropical gyres, as I already told you, and again telling, that these subtropical gyres are restricted in the subtropical regions around 30° north and 30° south mostly. Subtropical gyres rotate clockwise in the northern hemisphere, and they rotate counterclockwise in the southern hemisphere. Now here you can see the different occurrence of subtropical gyre: the North Atlantic subtropical gyre, the South Atlantic subtropical gyre, North Pacific, South Pacific, and Indian Ocean subtropical gyre. Now, if you look carefully, you can see that in each gyre, the warm current is found to occur along the western part of the ocean basin, which is moving from the equatorial regions towards higher latitudes in both hemispheres. In contrast, from the higher latitudes, the surface current that occurs towards the equatorial region, that is cold current carrying cold water towards the equatorial regions. Apart from these subtropical gyres, there are other kinds of currents are also found to occur over the earth. The first is the equatorial countercurrents. Now, in the subtropical gyre, what we see that due to the prevailing trade winds in the lower part or in the uh, equatorial region in the subtropical gyres, the movement of water is from east to west, that is from eastern margin of the ocean basin to the western margin of the ocean basin. Now, a large volume of water is driven westward due to these uh, equatorial currents. Now, the Coriolis effect is minimum near the equator. So, the majority of the water is not able to turn towards high latitude. Instead, the waters piled up and heaped along the western margin of any ocean basin. So, due to this piling of ocean water towards the western margin of the basin, it causes an average sea level increase in the western part of the ocean basin, and that sea level increase is in the value of about 2 meter sometimes. In contrast to the eastern side, the difference in sea level uh, found to occur in the western part of the basin and in the eastern part of the basin is almost sometimes reach about 2 meters. Now the water on the western part of the basin that then flows downhill under the influence of gravity. So here there is a pile up or heaping of ocean water occurs. Now as a result, as a counter effect, as the Coriolis effect is very low along the equator, the water in the western margin of the basin starts to flow from west to east along a very narrow zone along the equators. This flow of narrow ocean currents along the equatorial region is known as the equatorial countercurrents. So the trade winds, they drag or they force the ocean water to move towards the western margin of the basin close to the equatorial region. So there is a piling or heaping of ocean water in the western uh, part or western margin of the ocean basin. Now along the equator, The Coriolis effect is very small, so all the water that is not able to deflect or move towards higher latitude, and due to this, as there is a high difference between the western part of the basin and the eastern part of the basin, so water starts to flow from these low gravity areas towards the high gravity, that is towards the lower altitude eastern part of the basin. This current is known as the equatorial counter current. Apart from that, some gyres also found to occur in the subpolar condition, that is um, in the higher latitudes. Now, these subpolar gyres are formed when the northern and southern boundary currents of the subtropical gyres. This is the northern boundary current, and this is the southern boundary current of the subtropical gyre. They flow eastward as a result of the prevailing westerlies and eventually move into subpolar latitudes, that is around 60° north and south. Now here they are driven in a westerly direction by the polar easterlies. So when they reach in this condition, the polar easterlies drag them in an west west directed flow by the polar easterlies, and this will produce a circular movement in these high latitude condition, which occurs adjacent to the subtropical gyres. But the main difference of subpolar gyre from the subtropical one, that the sense of movement or the direction of ocean water movement is opposite in the subpolar gyres. So you can see in the uh, subtropical gyres, the move in the northern hemisphere, the movement was clockwise, whereas in the subpolar gyre in the northern hemisphere, the movement was anti-clockwise. Similarly, in the southern hemisphere also, in the subtropical gyre, the movement is anti-clockwise, but in the uh, subpolar gyre, the movement is clockwise. Now, subpolar gyres, in comparison to subtropical gyres, they are opposite in the direction of ocean water movement, as well as they are smaller and fewer in number compared to subtropical gyres. So you can see only two major subpolar gyres are occurred, that one in the northern hemisphere, this one, and one in the southern hemisphere, this one. Now, another important factor uh, which affect the circulation of ocean surface water. There are several factors like the Ekman transport, geostrophic current, western intensification of subtropical gyres, which affect the circulation pattern of subtropical gyres. Ekman transport is one of them. The effect of this Ekman spiral, first observed by a Norwegian explorer, Fritz Nansen. He observed that in the Arctic Ocean, the floating ice found over the ocean surface, that floating ice moved at an angle of 20° to 40° to the right of the prevailing wind direction. So if wind is blowing in this direction in the Arctic Ocean, then the floating ice is found to moving around 20 degree to 40 degree, in contrast to the this prevailing wind direction. So there is a deviation between the wind flow direction and the movement of floating ice in the Arctic Ocean. Now, not only the floating ice movement shows this deviation, but the surface water that are also found to show this kind of deviation both in the northern hemisphere and in the southern hemisphere. Now, to answer these kinds of deviation of surface water movement with respect to the prevailing wind direction, the Swedish physicist Walfred Ekman, he first developed a circulation model uh, in the year 1905, and according to his name, this kind of spiral motion or deviation of surface water with respect to prevailing wind direction is known as Ekman spiral, and the movement of surface ocean water is known as Ekman transport. Now, what happens in this Ekman spiral and Ekman transport? The Ekman spiral basically describe the speed and direction of flow of surface water at various depth. Ekman's model assumes that a column of water which is set in a motion by the wind activity, wind blowing activity, and during this movement, the Coriolis effect takes place in the surface of water. Due to the effect of Coriolis force or due to Coriolis effect, the immediate surface water moves in a direction about 45 degree towards right with respect to the prevailing wind direction in the northern hemisphere. Now, the surface water that moves as a thin layer on the top, and as the surface layer moves, the successive other layers found beneath, they are also set in a motion, and the transforming energy which the surface water gets from the blowing wind, that is circulated in the deeper part of the ocean water. So these portions of the ocean water that also start moving. Now the surface water change its flow direction with respect to the prevailing flow direction, prevailing wind flow direction at an angle of 45 degree. So each surface, each subsurface layer of um, ocean water that set in motion, and as the energy is transforming from surface to the deeper part, so they becomes progressively slower, that means progressively slower in velocity, and as a result of the Coriolis effect, they bend or they deviate more towards right hand side, more towards clockwise direction in the northern hemisphere. So with continual deviation of ocean waters at different layers, after some depth, it was found that a layer of water is moving exactly opposite to the prevailing wind direction. So in every layer, the deviation of ocean water movement occurs. In the surface, it is occurring about 45 degree. Now, if we go below the second layer, that also deviates with respect to its previous one at some angle. So at every layer in this surface ocean water, uh, some kinds of deviation occurs. And after some depth, it was found that the ocean water moves exactly opposite to the direction of the prevailing wind. Now, with further increase in depth, the frictional resistance, because in every layer, when one layer has to move with respect to other layers, that is the layer above and below it, it face some kinds of restriction to move. So with every layer, the transmission of energy becomes lower and lower. And after some depths, it was found that the entire energy is consumed and there is no motion found to occur after certain depth. Now, the depth up to which the movement of ocean surface water is found to occur, that depends on the energy condition of the prevailing wind direction. That is how much energy is transformed from the wind to the ocean surface water. It was found that in an average, the topmost 100 meter of the ocean surface is affected some amount by the prevailing wind flow. Now, under ideal condition, the surface layer should move at an angle of 45 degrees from the direction of prevailing wind. Now, if we combine all these ocean surface layers, we can see that there is a net water movement with respect to the prevailing wind direction, and this net water movement is 90 degree from the direction of prevailing wind. This average movement of ocean water with respect to prevailing wind direction is known as Ekman transport. In the northern hemisphere, it is about 90 degree to the right, and in the southern hemisphere, it is about 90 degree to the left. So due to the Ekman transport, the average movement or the net water movement, because you can see that all the surface ocean waters, they move at different angle, so they have different directions with respect to the wind flow directions. If we sum up all the directions, then you can see that a net movement, an average movement of ocean waters with respect to prevailing wind direction is found to occur, and that occurs at 90 degree to the wind flow direction. This is known as Ekman transport. Next is the geostrophic current, movement of water in the subtropical gyres. Here the force exerted by the wind, that is the wind stress on the ocean surface water, is proportional to the square of the wind speed. So basically, how much force, how much stress is acting over the ocean surface water, that depends on the um, speed of the wind. Now, this produce not only ocean waves, because wind is also the reason for which the waves in the oceans formed, but also they inject some momentum into the surface layer of the ocean, due to which the surface layer moves towards the, more or less towards the wind flow direction. Now, due to the Coriolis force or Coriolis effect, the surface layer of the ocean water move not exactly in the direction of prevailing wind, but at an angle. Now, generally, it was found that wind changes its strength and direction from place to place. So, in some regions, the Ekman transport forces accumulation or convergence of surface water at a certain point, whereas in other region, due to the Ekman transport, divergence or removal of surface water found to occur. Here you can see that in the first case, due to Ekman transport, due to different direction of wind at different places and difference in their strength, there formed certain conditions where it was found that the ocean surface water are accumulating in a certain place. So due to this accumulation, a large amount of water now piled up over a certain point or over a certain place due to this convergence. Similarly, at certain points, due to the different direction of wind, due to different reasons, and the effect of Coriolis force, it was found that ocean surface water is diverging, that is, goes away from any certain point, from any certain place. So here, a removal of surface ocean water occurs. So basically, a thinning of surface ocean water happens. And in the case of convergence, thickening of surface ocean water found to occur. Now, the thickening or thinning of the surface ocean water due to Ekman transport, that produces hills. So hills are produced in the place of convergence, that is mounding or piling up of ocean surface water, and some valleys or depressions are found to occur in the ocean surface where there is divergence or removal of ocean surface water happens. Now, the total relief of the ocean surface due to this uh, convergence and divergence, the difference in relief happened in these two cases is about 1.2 meter. Now, due to the convergence and divergence of surface water, which basically causes hill and valleys of the sea surface water, they produce a horizontal gradient of pressure. So in the point or in the place of convergence, a lot of water being piled up. So it forms a high pressure areas. In contrast, in the place or in the point of divergence, water is moving away from that point. So here forms a low pressure zone. Now, due to this horizontal pressure gradient, so one point which is in high pressure and one point which is in low pressure, a difference in pressure occurs. And due to these pressure gradients, the water move from the high pressure towards the low pressure regions or low pressure points. Now, during this movement from high pressure to low pressure point, the Coriolis force starts its action. And during this movement, Coriolis force bends the direction of water movement. So you can see from the top view of the gyre that when from this high pressure point, that is the central point of the gyre, the water is moving towards the low pressure zone, towards the peripheral part of the gyre due to the pressure gradient, a clockwise change in direction of ocean water found to occur. Now, eventually, a balance is found to occur between the two forces. The first one, that is the horizontal pressure gradient, and the second one, that is the Coriolis force or Coriolis effect. But interestingly, both these forces are found to occur in the opposite direction. Now, the condition when there is a balance, that is the pressure gradient force equals the Coriolis force, the condition or the balance is known as geostrophic balance, and at that time the current which is moving is known as geostrophic current. Now, in this condition or in this picture, you can see another interesting feature or another factor which guides the movement of the surfacial water in the subtropical gyre. You can see that this mound of ocean surface water, due to the convergence or divergence of ocean surface water, this mound is not symmetrical. Rather, the top point or highest point of this surface ocean water mound is more close to the western side, that is more close to the western boundary of the gyre. Now, as a result, the western boundary currents of the subtropical gyres, they become a faster, narrower boundary currents. In contrast, the eastern currents, they have a large area and relatively slow moving currents. So you can see that there is a change in pressure gradient with respect to distance as the high pressure point, that is the apex of the mound, is more towards the western boundary. So in the western part of this mound you can see a steeper gradient, whereas in the eastern part a gentle gradient. So because of this steeper gradient, the western boundary current of the subtropical gyre is a fast moving narrow region covering current, whereas the eastern boundary current is a slow moving and covering a much larger area. This process by which there is a intensification observed in the western part of the basin This is known as western intensification. Now, if we look at the global surface current flow, the global surface current flow in this picture, you can see the white arrows. They are moving from one place to another, and you can see the different gyres. You can recognize the subtropical gyres near the tropical region and the polar gyres near the high latitude polar conditions. Now coming to the second part of the ocean current or second type of ocean current, that is the mainly due to difference in temperature of ocean water and difference in salinity of ocean water. Now density is directly proportional to salinity, as with increase in salinity more and more solids or more and more salts is added to the solution, so thereby increase in mass occurs and thereby density will also increase. So this way, with change in salinity, the density of water is affected. In case of temperature, it is found that temperature is inversely related to the change in density. That means with increase in temperature, density will decrease. That is, with increasing temperature, the volume of ocean water increase. So thereby the molecules with increasing volume becomes far away from each other. So density will automatically decrease. Now, due to this difference of different physical factors like salinity and temperature, the density of water changes from place to place. So the region which have higher density water at that place, due to this higher density, water mass sinks, and the region which have lower density water, due to the low density, water mass floats. So that creates a circular motion of deep ocean water from by sinking of high density ocean water at some point and upwelling of low density water at some other point. As I already told you, deep ocean circulation is driven mainly by temperature and salinity, which basically affects the density of the ocean water. This deep ocean circulation, as it occurs in a circular path or circular belt, so it is also referred as the conveyor belt. It occurs below the pycnocline. 90% of all ocean water is affected, and the most important thing that this deep water ocean movement is very slow in velocity. So in a simple comparison, the distance covered by the ocean surface current in 1 year, that distance may be covered by the deep ocean currents by 1 year. So you can see the uh, distance and the speed difference between the surface ocean currents and the deep ocean currents. In general, a approximation of deep ocean currents to complete its entire path is found to occur about 1,000 years. Often it is found to occur in more time to take. Now, the deep ocean currents originates basically in the high latitudes where the ocean water or the temperature is very cold. So with decrease in temperature, the ocean water decreases in volume and becomes more denser. So sinking occurs in the higher latitudes. This cold dense water sinks at these regions and moves as a bottom current towards the equatorial regions. Towards the equatorial regions where the ocean water is relatively hot, the volume is higher and density is lower. Here, this cool water coming from the polar regions goes up close to the picnic line. So in this way, a global circulation of deep ocean current found to occur across different latitude conditions. Now, some of the deep water masses are the Antarctic bottom water, North Atlantic deep water, Antarctic intermediate water. These are the examples of some of the uh, deep cold water masses coming towards the equatorial regions. Here you can see the conveyor belt movement of deep ocean currents. So you can see a flow, a broad flow from low latitudes to high latitudes. The red portion indicating the warm current that occurs close to the pycnocline, whereas the blue line or blue shaded zone indicates the deep, cold, denser current which occurs along the ocean bottom, and that water coming from the cold polar regions. Now, although I told you that there is a circulation from equator to polar region and from polar region again to the equator, but these are also affected by the distribution of continents as well as their shapes. So bottom water current or deep water current, which is governed by the density contrast of ocean water, that is also affected by the distribution as well as the shape of the continents. Now, one major phenomenon or rather two major phenomenon is found to occur in these deep ocean currents, that is the vertical movement of ocean water, which is known as upwelling and downwelling. Upwelling is the vertical movement of cold, nutrient rich ocean bottom water close to the pycnocline, that is close to the topmost part of the um, ocean bottom water. As they are coming close to the surface, so among them they will carry a high amount of nutrients with them. So the organisms living close to the pycnoclines, they got this nutrient, and that is why the regions of upwelling where these kinds of upwelling occur and the regions become nutrient rich, they have a high biological productivity. So we expect higher diversity of organisms in these upwelling regions. In contrast, downwelling occurs when the vertical movement of occurs of deep ocean current um, goes below, far below, and reach the ocean bottoms. And in this portion, in this case, there is no nutrient supply because the close to the pycnocline water, that water goes below. So no supply of nutrients. So these are the less productive area in terms of biological activity. Now coming to the coastal upwelling, this is one important part or important thing. That is why we found that most of the uh, biotic bodies, they are mostly found along the coastal areas. That is, the diversity and the abundance are found along the coastal regions of the continent. Now, this kind of coastal upwelling happen when the prevailing wind direction occurs parallel to the coast. Now, the coastline, due to the Ekman transport, that is due to the effect of Coriolis force, this moving body of wind or this moving wind drags the ocean surface water also. Now, as Coriolis effect is acting over the surface water, so literally the ocean surface water is moving at an angle with the prevailing wind direction. Now, wind is moving parallel to the uh, coastline, and due to the Coriolis effect, the surface ocean water moves at an angle with the coastline. In the northern hemisphere, it moves right, and that results of surface water moving away from the coastal areas. So as the surface water is moving away from the coast, that vacant place is now taken from the bottom ocean water. So due to this wind movement parallel to the coastal area, there form a circular sail close to the coastal region. The ocean surface water moves away from the coast, moves far towards offshore regions, and that vacant place is now taken by the ocean bottom water. So you can see that an upwelling occurs, and due to this upwelling, lots of nutrients comes close to the surface water and comes close to the coastal regions. So that becomes a highly productive region where lots of biological activity found to take place. Now, apart from the Coriolis effect and X-band transport by which uh, coastal upwelling is found to occur, there are other types by which upwelling of ocean bottom water can take place. The first is the offshore winds. If there is a wind moving from the land areas towards ocean water. So with this moving, it drags the ocean surface water, so that vacant place is filled up by the bottom ocean water. So again, there is a circular sail generates an upwelling of bottom ocean water found to occur. Now there is a difference of this offshore wind and the previous coastal upwelling. In the previous case, the coastal upwelling, the movement of wind is parallel to the coast, whereas in this case, the movement of wind is across coast and wind moving from land to sea. That is a land bridge moving towards sea, and during its movement, it drags the ocean surface water more towards offshore regions. The second process by which upwelling is occurred, that is the if there is a obstruction in the sea floor. So with movement of sea water as bottom current, as deep current, if it face any kind of restriction, then along the restriction side, some kinds of upwelling of ocean water also found to occur. The third way by which upwelling occur is the coastal geometry. If the coastal geometry is somewhat in this kind of fashion. Now there is a movement of wind along the coast, and due to this surface current is found to occur along the coast, but due to this pattern of coastal geometry, here you can see a portion where there is no such movement of ocean surface water. So locally there forms a uh, circular sail across the depth of oceans, because the surface water is being taken away and this portion water is now trying to fill up that portion, so the bottom water is now coming to the surface. So a circular shell is also acting here, because it's a hidden place from this general movement of the ocean surface water flow parallel to the coastal region. The other vertical movement, that is downwelling, in the coastal region, downwelling is also found to occur. The surface water moves towards each other, they converge, becomes a high pressure region, and due to this high pressure region, the water moves vertically to the bottom of the ocean surface. So downwelling of ocean water occurs due to convergence of surface ocean water. Now, as there is downwelling, so the superficial water becomes nutrient poor, so low biological productivity is found to occur in these cases. Apart from this, in the coastal areas, wind flow is also takes place, and they also they also results in coastal downwelling. In case of coastal upwelling, we see that wind flow is from this side to this side. In case of coastal downwelling, you can see the prevailing wind flow direction is from this side to this side in the northern hemisphere. So in the northern hemisphere, when wind flow in this direction, particularly in the western coast of the continental landmass, due to the rotation of Earth, that is due to the Coriolis effect, the surface water is now being taken, or surface water is now deviating direction more towards coastal areas. So wind drags the surface water along with its flow direction. Due to the Coriolis effect, this surface water bends towards the coastal areas. So more and more water is found to pile up along the coastal areas, and that again promotes a circular shell with downwelling along the coastal areas, and upwelling occurs more in the offshore regions. Now, as downwelling occurs in this case along the coastal areas, so these areas are nutrient poor and they lack marine life or any kind of biological bodies, very poor in biological activity. Apart from that, a peculiar type of movement of ocean water found around the Antarctic landmass. Here, two types of movement of ocean water found. The first one is due to east wind drift, that is a surface current which is governed by the polar easterlies, that is the polar water coming towards the lower latitude portion, and it moves anti-clockwise. Here you can see around the Antarctica landmass, this polar uh, movement of polar easterlies, and by which the surface ocean current around Antarctica occurs as east wind drift, rotates surrounding the Antarctica landmass in a narrow zone uh, in a counterclockwise fashion. Apart from that, the current coming from the tropical to subtropical regions that hit the front around 60-degree south latitude condition, and that is the west wind drift, and due to that the movement of water coming from the subtropical regions towards the 60 degree south latitude condition. The water now again moving, encircling the Antarctica landmass in a much broader area, and this is known as penguin gyre. Now, this gyre, this subpolar or polar gyre, is the only current found to occur in Earth which crosses all the longitudes. That is why it is also known as circumpolar current. It is encircling the southern pole. It is encircling the southern pole landmass, that is Antarctica. Now, if you look at the climates, that is the effect of ocean currents on climate, the ocean currents have a huge impact governing climate globally as well as locally. Warm ocean currents warm the air at the coast, so the coastal areas which have warm ocean currents, particularly the um, eastern part or eastern coast of the continental landmass, which receives these warm ocean currents, the coastal areas becomes warm, the air is close to saturation with water vapor, that is the condition is very humid, and lots of evaporation, lots of formation of clouds occur. So lots of rainfalls are also found to occur in these regions. In contrast, the western part of the continental landmass, which basically receives the cool ocean currents coming from higher latitudes, although the regions are relatively cool, but the atmosphere is very dry, there is less water vapor, so almost there is no formation of clouds, and precipitation is very low. The ocean covers around 71% of the uh, water body of the planet, and it holds about 97% of the total global water content. So, due to this huge amount of water content in the ocean, they becomes a key factor in the storage and transfer of heat across the globe. The movement of heat through local and global ocean currents affect the regulation of local weather conditions and temperature extremities, thereby stabilizing the global heat distribution at different latitude conditions, and thereby affect the global climate pattern. Not only that, the ocean water also act as a natural reservoir for many of the toxic greenhouse gases, say for example carbon dioxide. Due to the circulation of ocean water, due to different currents, some areas, some coastal areas um, are the sites of upwelling, so lots of nutrients supplied in those areas, and that regions become a prolific region for high biological activity. So marine ecosystems, they are also affected by the ocean currents. The upwelling sites, they having the high marine life, whereas the downwelling sites, their marine life is very poor. Now, an interesting thing, you can see that two areas, one in the Greenland and one in the Norway, they are situating at almost same latitude condition in the northern hemisphere, about 70° north in both margins of North Atlantic Ocean. But you can see that the Greenland area is the sea, there you can see the lots of icebergs. That means the eastern coast of Greenland is basically a cold, very cold area, cold, dry condition. Whereas in the western coast of Norway at Somo, here you can see a hot, relatively humid condition exist. So at the same latitude conditions, there exist two different climatic condition in two different land masses on the two sides, on the two margins of the same ocean basins. And this difference is occur due to the polar gyre, that is the cold, dense water coming from the North Pole or Arctic region towards the low latitudes along the western margin of the Atlantic Ocean. So the Greenland areas, they receives the cold ocean water, surface water, whereas after encircling the subpolar regions, when it receives much amount of heat from these lower latitudes, when it goes back again to the higher latitudes along the eastern margin of the North Atlantic, the coastal areas of Norway, that receives a warm surface ocean water. So that is why in Norway you can see a warm condition exist. So you can see that locally, due to the surface ocean currents, how at the more or less at the same latitude conditions at two margins of a same ocean basins, there exist two different weather conditions. So thank you. That's a brief idea about the ocean currents. Thank you.